Example 20.1 asks us to use properties of logarithms, which I have for us here. That would be the product rule, the quotient rule, and the power rule, to expand the logarithm as much as possible. And then there's another line that says, where possible, evaluate the logarithmic expressions without a calculator. We saw that in section 19. I want to focus now on the expanding part. It says here for part A, log base 8 of 13 times 7. Now remember, with the product rule, there's an implied multiplication in between the m and the n. So we can think of 13 as being m and 7 as being n. So we can expand this into multiple logs by making the left-hand side look like the right-hand side using this equivalency. So we can expand this to say log base 8, and then I'm going to use 13 as the argument for the first log, and then I'll say plus log base 8 and 7 for the second log. And then this is really all we're looking for. This is called the expansion of the logarithm. Let's try this with part B. We have log base 9 of 9 divided by x. This is going to be analogous to the quotient rule. We have m, which is the numerator, n representing the denominator. So we can expand this using 9 for the first argument. We'll use x for the second argument, and then between the two logs we now have subtraction. And this is what we would call the expansion. Now, this particular example also has the ability to have a logarithmic expression evaluated. That's going to be the log base 9 of 9. If we look at log base 9 of 9 and set it equal to a question mark, then I would get the statement 9 to the question mark needs to equal 9. And there's only one exponent that makes that true, and that would be 1. So that's what that bottom sentence says, where possible, evaluate the logarithmic expression without a calculator. That's what this is. So now we can say 1 minus log base 9 of x. And that ends up being the final answer after we've expanded and then evaluated wherever possible. So let's try this with part C. We have the natural log of e to the 4 divided by 8. There's two things that we have to be considerate of on this one. We have division, and then we also have a power. Now, if I'm going to do division, then I would take e to the 4 as the numerator, 8 as my denominator. If I'm going to use the power, then the power is only going to use the 4 and the base that it's attached to, which is just the e. So there's a implication here with the power rule that the p, which is the power on your argument, has to apply to the entire argument. So right here where it says m raised to the p, that's really the same as saying log base b of m, and then the whole m is being raised to that power. So if the entire argument is not being raised to the power, then you can't apply the power rule. So that's one of those implications, one of those little details that you really have to pay close attention to with that power rule. So I'm not going to use the power rule right away, I can't, but instead I'm going to use the quotient rule. And with the quotient rule, I can expand this natural log of the numerator minus the natural log of the denominator. And I'm using parentheses here for the argument. You don't have to, but it's something that I like to do sometimes. And then once I've done that first level of expansion, then I can go back and reevaluate and see if maybe I could apply another rule, like the power rule. So then I look at 4 and notice that 4 is the power for the entire argument now, since e is the only other thing that's there. So I can apply the power rule now just to this one part of the expansion, and this is now going to say 4 times the natural log of e minus the natural log of 8. And then the natural log of e is going to end up being one of those expressions that we could evaluate without a calculator, and it's going to end up becoming 1. So the final look on this is going to be 4 minus the natural log of 8. Part D, log base b of x times y to the third. So we're going to run into the same problem with the power that we did on part C. The power, which is 3, only applies to the y. It doesn't apply to the x and the y. So we can't immediately start with the power rule. But we can think of this as a product with x multiplied by y to the third. So we'll expand using the product rule, log base b of x plus log base b of y to the third. And then the y to the third is the argument for that second log, which means that 3 is only applying to the y. And since y is the only other thing there, I am permitted to bring it down just as the coefficient for that log. So this will then read log base b of x plus 3 times log base b of y. We got 2 more, part E and part F. For part E, I see 64 in the numerator, square root of x plus 1 in the denominator. Seems like a good use of the quotient rule. We'll write this as log base 8 of 64 minus log base 8 of the square root of x plus 1. The log base 8 of 64, you can evaluate that without a calculator. That's going to end up being 2. And the log base 8 of the square root of x plus 1 needs to be written so that way the square root is represented as an exponent. So the argument is going to be x plus 1 raised to the 1/2. And I do that because the power rule would then apply, where I can take the 1/2 and bring it in front of my log, and my final look on this will be 2 minus 1/2 of log base 8 of x plus 1. Last example, we have the ln, and we have the square brackets here to represent the argument of this log. So there's a lot going on here. We have x to the 4, we have the square root of x squared plus 3, we also have the x plus 3 raised to the 5th. So I'm going to take the entire numerator and the entire denominator, and I'm going to apply the quotient rule. This is the very first step that I would have to take. I could not use the product rule because the product rule would only apply to the x to the 4 and then the square root of x squared plus 3. It wouldn't include the denominator. I want to make sure that whatever property, whatever rule I apply first, or really any time, has to apply to the entire argument. So this is why the quotient rule is a good place to start. So we're going to say ln of the numerator minus ln of the denominator. Once I do that initial expansion, go back and look to see, could I expand any more? And we can. The x to the 4 and then the square root of x squared plus 3 is now the product in that first argument. And then in the second log, I have 5 as the power for that argument. So once you do that initial expansion, then you can start to see how other rules become available. So that first log will now become 2, natural log of x to the 4 plus the natural log of the square root of x squared plus 3, and then minus 5 times the natural log of x plus 3. So go back and look at it again. Is there another iteration of a rule that could be applied? So we have a power of 4 on the x. That can be brought down in front of that first log. We also have a square root, which has the implied 1/2 exponent. That can also be brought down in front. And then the last statement is already had the power brought in front, so nothing else to do with that. So here's our final statement. We have 4 ln of x plus 1/2 ln of x squared plus 3 minus 5 times ln of x plus 3.